Hi everybody, I have good news. So I just figured out why the audio and video, well, maybe not why, but the audio and video I noticed wasn't syncing up on prior videos. And so the good news is that I just restarted my iPad and I've done some tests and I noticed that it is syncing up correctly now. So since we've done the Pythagorean theorem, we're going to move back then to the beginning of chapter 6, or section 6, I should say, where we're going to talk about the geometric mean. So the first thing, knowing the definition of the geometric mean, so if we have two values a and b, then its geometric mean is going to be calculated by doing the square root of the product of those two numbers. Now we can also do this if we have more values as well. So for three of them, a, b, and c, we can find it by doing the cube root of the product of those three. And then lastly, if we have n values, so any number of values, we can multiply them all together and then take the nth root of those in order to get our answer. Now, I know for some of you, your calculators may not be able to do all of these calculations, so you can also use fractional exponents. The first one is going to be the same thing as ab to the 1/2 power. Second one is ab to the 1/3 power. And whatever the value of n is, oh, whoops, I'm sorry, I should have written abc to the 1/3 power. And then for the last one, all of those, a1, a2, all the way to an, raised to the 1 over n power. Now, just so you're aware then, you are already familiar with the arithmetic mean. That's the one where we had to add all of our things together and we divided by how many we have. That's used then whenever your values typically are supposed to be added together. So for example, if I'm talking about how many candy bars I have and then how many candy bars you have, we want to be able to add those together and then divide by 2 to find the average candy bars between you and me. Whereas for the geometric mean, we want to use that then when values are typically multiplied together. So then the cube root then there of ABC. And so an example, I'm actually going to show you on the next couple slides some examples then of where geometric mean is going to be useful. So the first one, well, the name says geometric, we're going to just stick with geometry. So first thing, we're going to find the square that has the same area as this rectangle. The way that we can do that, if we just multiply 2 times 8, well, we know then that that's going to be 16. And if we were to then take the square root of that, then that means that's going to be the square root of 16. We would get 4. And we know then that a square with side lengths of 4 is indeed going to give us an area of 16. And then the same thing will be true down here at the bottom then. Find the cube that has the same volume as the prism. If we multiply the three values together to find the volume, this one here, 20 times 2 times 12.8, is going to get us 512. Now, if we were to do the cube root of 512, give me a second here, that's going to become 8. So a cube that has side lengths of 8 is going to get us the exact same volume as the prism over here on the left side. Now, another important use for the geometric mean is going to be when we're talking about how, like, what percentage is something changing. So, no, that's not actually your car, although I do think it's still kind of funny. Your car is originally worth $40,000. We're going to say that you keep 30% of its value after the first year, 90% after the second, and then 80% after the third. And we want to find the average percent value that your car kept each year. So what we would normally do is we would typically just say, well, what's 40,000? And it's keeping 30% of its value. So we would just say, okay, 40,000 times 0.3. And we would say, okay, after the first year, the car has dropped to be $12,000. Then the second year, we're going to take that and multiply by 0.9. And we would have 10,800. And then for the third year, we would multiply, and it would be times 0.8. And that would give us, after 3 years, the car is only worth $8,640. So we can then use the geometric mean. Instead of having to do times 0.3 times 0.9 and then times 0.8, we could instead find the geometric mean and then just know that we could have multiplied by that value every single year and we would get the same amount. So what that will look like is this. I'm going to do 0.3 times 0.9 times 0.8. Since there's three numbers, I'm going to do the cube root of that. And it turns out that when we do the cube root, this here ends up being, I should have shown you what we get first. We are going to have 0.216, and the cube root of 0.216 ends up being 0.6. And to show you then that this is correct, what I'm going to do now is I'm going to recalculate the value of the car after the 3 years, but this time I'm going to multiply by 0.6 each time. So 40,000 times 0.6 is going to be 24,000. Now we're going to do 24,000 times 0.6. 14,400. And lastly, if we do 14,400 times 0.6, we do indeed get $8,640. So this example shows us that if we wanted to know the average amount that the car was changing each year, it kept on average 60% of its value, even though the first year was 30%, second year was 90%, and then the third year was 80%. So that's another way where geometric mean can be useful. It's often used in financial situations. So banks might use this for interest rates. If the interest rate is changing year to year, they can calculate the geometric mean to find what was the average interest rate then. Oh, I'm sorry. There's one more thing I should have shown you. Some of you may be thinking then that we could have just added those interest rates, not interest rates, we could have just added those percentages together and then divided by 3 in order to get the same value. But I'm going to demonstrate to you then why that is not going to work. So we're going to start with 0.3 plus 0.9 plus 0.8, and we're going to divide that by 3. We're going to get 2 divided by 3, so this ends up being it is 2/3, or 0.6 repeating. Now I'm going to demonstrate why this is not going to work for us, because if we try doing 40,000 times 2/3, so we're going to get 26,666 and then 0.6 repeating. Now we're going to multiply that again. This time we get 17,777 and 0.7 repeating. And if we do it one last time, what we get then is $11,851 and about 85 cents. And if you wanted to know, it actually is going to be, that's the decimal that's repeating. So you can see this was supposed to be the correct amount, but when we found the arithmetic mean, this here, we did not get the correct amount that the car was valued. So that's why the geometric mean was useful in this situation. Back from earlier, I said you want to use geometric mean when you had values that needed to be multiplied together rather than adding them together. Okay, now let's move on. So the proof of the geometric mean. So what we have here is this picture. We've got a big right triangle, and then we've got 2 smaller right triangles in it. We've got that one right there, and then we've got this right triangle right here. And so what we're going to do, we need to break apart those 2 smaller triangles. So I'm going to take one of them, Draw it right there. And that is triangle ABH. And the lengths that we have are H, little h I should say, C and M. And then we're going to have our bigger triangle here, and there's our right angle. That is AHC. And there we have H, B, and N. Now, I'm going to let you know that these triangles are similar. And since they are similar, then what we can do is we can set up a ratio. And we're going to use our corresponding sides. So I'm going to label these circling and also by using colors. So hopefully you can see that the shortest side in the triangle down here is H. And the side in the other triangle that corresponds is the shortest side, M. So that is going to be one set of our corresponding sides. Then we have to find the other set that we want to use. So I noticed that I already used M, which was next to this right angle here. So the next one I'm going to do is I'm going to pick H. However, I should be careful. M was on the bottom of the fraction because it's in the second triangle, the small triangle I should say. So I'm going to put H in the bottom for this as well. We have to make sure that we keep in this fraction everything from the bigger triangle goes on top, everything from the smaller triangle goes on bottom. Then for the second part, over in this triangle, the other side, the other leg that we did not use was N. And now to get to our result up at the top, we just need to cross multiply. H times H gets us H squared. Over on the other side, we get M times N. And that is why we have this theorem. So that formula is going to be used by us a lot for today. In this first example, now I covered up that side right there because that was already given in the Savas notes, and I don't want you to just jump to the Pythagorean theorem. I understand that you know how to do it, especially since we just covered that in our last video, but I really want to demonstrate how this would look then with the geometric mean. So according to our formula, here is M, which is already labeled. 1.8 is going to be the N, and then 2.4 is the H. So we know from our formula, H squared equals M times N. So we should go ahead and put in our values. 2.4 squared, then it's going to be M times 1.8. Now, when we get 2.4 squared, that is 5.76. We should divide by 1.8. And we get 3.2 as the answer. Now, I did say we could check our work if we wanted to. So, I'm sorry, I wasn't thinking. I thought I would be able to drag that off, and apparently I cannot. So, what I'm going to do is I'm going to check what the original notes were just so that I can see what that value was. And that value was originally 4. So if that was 4, we're going to check our work then with the Pythagorean theorem. We know that 4 squared, so check. We're going to know that 4 squared is going to be equal to M squared plus 2.4 squared. We've already figured out that 2.4 squared is 5.76. And we got 16. We subtract. And that is going to leave us then with 10.24. And then the square root of that is indeed 3.2. Good. All right, in this question then, you are given PQ and QN, so go ahead and use those in order to find MQ. Pause the video. When you are done, I'll show you how to do this. Okay, now that you have done that, I am going to demonstrate here. We've got PQ is 9 and we've got Qn is 4, and we needed to find MQ, so that's our H. We know from our formula it's H squared equals 9 squared, sorry, not 9 squared, but 9 times 4. So we'll get H squared equals 36. And then just the square root of both sides tells us that H is 6. Good. Now we have another theorem then, and I'm not going to go through the proof for this, but we will be using these formulas as well, and you do need to remember them. So the first one is that b squared is going to be equal to a times n. And then the second one that we are going to use is that c squared is going to be equal to m times a, or as I wrote, am. So just think of it as your hypotenuse. So again, I'll go back and show you with b. Just think of it as your hypotenuse then of that smaller triangle is going to be equal to the length of the entire triangle times the other leg from your small triangle. Okay, so for this first one, we're going to find the value of x. And what I can see is that we have this 25 down at the bottom, and we've got this part is 24. And what I'm thinking is we might need to find some other values before we can solve this. And specifically what I'm thinking of is I think we need to find HC first. So it's kind of interesting that it says that that's in part B, but I think that we actually do need to find that as our first value. So I'm going to label that as Y, and we know then from, so we're going to start with B actually. CH is going to be 24 squared equals Y times 25. Okay. 24 squared is 576. We need to divide by 25. And we get 23.04. So I will go ahead and I will write that in. And because we know that that is 23.04, then we can find what BH is. And that's going to be 25 minus 23.04. And that's going to be 1.96. And now that we have found that, we can go ahead and finish by getting x, because we can use the formula from earlier that we learned. It's going to be x squared equals, and then we're going to multiply these two values here that we just found, 1.96 times 23.04. X is going to be equal to the square root of that product. And that product ended up being 45.1584. And when we take the square root of that, we get, that actually works out pretty nicely. 6.72 is the length of x. Okay, so go ahead and on your own, I want you to find the missing value in the triangle. Pause the video. When you are done, I will show you how to do it. Alright, so we know that PM is going to be 12, and we know that PQ is 9, and we were supposed to find PN, which I'm going to call X. So looking at this then, we have in this right triangle, the 12 is that hypotenuse, so that's going to be the part that is squared. And then it's supposed to be the small side times the long side, so 9 times x. 12 squared is 144. Then we just have to divide by 9. And I believe that is 16 off the top of my head. Yes. 16 equals the missing value. Okay, once again, try this question, pause the video. When you are done, start it up again, and I will show you how to do it. All right, so we know that AC is 15, AD is 5, and we're supposed to find DB here. So I'm going to call that one X. So looking at this, my thought is that we should find what DC is, which I will label Y. And once we have that, then there will be enough information in order for us to find X. Although, you know what? There's another way we could solve it. You could either do it this way, Pythagorean theorem with these three, and then you can use the geometric mean with those three. Or another way that we could solve this, let's find that right there. And let's do A, 5, and 15. I think that will work, or that will work as well, I should say. So that means that we will have 15 squared equals 5 times A. 15 squared, I think that's 225, yes. We will divide both of those by 5, and we get 45 for A. And now that we know that that is 45, then we just need to subtract it with 5, and we find then that X is going to be 40. All right, here's another one. Once again, pause the video, try it on your own, and when you are done, start it up, and I will show you how to solve it. Okay, so this time we have AC is 6, CB is 24, and we are supposed to find CD, so we're going to call that one X. So I'm looking at this, and you know what? I'm actually a little stuck. I have to apologize for that. Give me 1 second. I'm going to go double check on this. So I thought it was going to be more obvious when I was looking at it, and I realized that we're missing a few values that I assumed would be easier. Oh, I remember now. Okay. So we need to introduce a couple other values in here. I should say other variables. And let's start by finding this part right here. I was thinking of that, but I didn't really see immediately how that was going to help. But we do, in fact, need to use that. So we are going to have 6 squared plus 24 squared is going to be equal to, and I'm going to just call that A for now, so A squared. So we're going to get 36, and I'm pretty certain that's 576 there. Yep. So we're going to get 612. Then we need to take the square root of both of those. And 612 does not simplify well. Just so you are aware, if we do try to simplify it, let's see, we can break that up into square root of 4, square root of 9, and square root of 17. So we're going to get 2 times 3, so 6 root 17. Not sure if that's really going to help us, the fact that we simplified that, but we just did. So we're going to roll with it. Okay. Then what we need to do next is that let's see. Oh yeah, we've got our similar figures. So I'm going to break this up into smaller pieces then. We are going to have that triangle there, and I'm just going to keep them close to each other, and then there's that triangle there. we know that this is x, we know that this is 6, we know that this is x, we know that this is 24. And so we have some sides that are going to go together. And we have, let's see, sorry, I'm pausing because I'm wondering why exactly did I um hmm. This is what I get for not practicing this question before I started doing the notes here. I must apologize for this. I honestly am stuck, to be honest. CB and so I'm looking at the notes from Sabas, and they're saying that those two go together, which I do see that. And then let's see. Then we got BA and CA. Oh, so then it, but those aren't, they are part of the same triangle. Oh, got it. Okay. Now we're back on track. We can cross multiply. We can actually get rid of those 6's. I see what it was trying to do. Okay, so we did not need that triangle. What we actually did was, okay. Let me explain what I just did here so that you can see where I got everything. So I'm going to just erase those first, and I'm going to start by labeling the 24 and the x come from this big triangle here, and then the smaller triangle there. And what I did was this 24 pairs with that x. So that's how I got this fraction here. Then for the second part, we know that the 6 square root of 17 is similar to the side that is 6 right there, and so that's how I got the second fraction. Now that we've put that together, then we can solve this. That's 1. So we get 24 equals x times square root 17, and then we have to divide both of those by the square root of 17. So we get 24 over the square root of 17. Just so you know, it is improper for us to leave a square root in the denominator, so we need to multiply top and bottom by square root 17. And that gives us then x equals 24 root 17 all over 17. Sorry about that, everybody. That was a lot worse than I expected it would be. Alright, so one more question then. Once again, pause the video, try it on your own. This time, I hope that I will be able to help you with it. Okay, now that you have tried it, let's see, let's cross our fingers that this one does not turn out to be as bad as the last one. So we're given those values, we are supposed to be finding an HB. I already can see this is going to go a lot better. I can see exactly how we're supposed to solve it. We're going to have 8 squared equals, and then it's supposed to be x times, and then we need the entire length, so we're going to have to add these together, x plus 12. So now we're going to get 64 on the left side. Over on the right side, when we distribute that, we're going to get x squared plus 12x. We should subtract 64 from both sides, because we will need to factor. And we have to think of what is going to multiply to make negative 64, but it's going to add to make positive 12. So for negative 64, I'm going to ignore 64 and 1. There's no way that those will add or subtract to make 12. 32 and 2, same thing. So instead, I'm going to go to, let's see, I'm going to try 4 and 21. Well, that can't add or subtract to negative 12, so that's wrong. 5 doesn't work, 6 doesn't work, 7, 8. Can we do 8 and 8? Looking at this, no, we cannot add or subtract 8 and 8 to make 12. So what else is going to work then? Can't do 12, can't do 14. Did I say 21 and 4? Wow. This is not going well for me. I'm sorry. 16 and 4 is what it's supposed to be. And in order to add or subtract, it's supposed to be negative 4. Wow. I am so sorry, everybody. So we're going to get then, if we factor x minus 4 and x plus 16. So now we know that our possible solutions are positive 4 and negative 16. And the last thing is that we just need to check which of those seem reasonable. And I can tell that from here we're supposed to get an x and we're supposed to have an x plus 12. If we put in negative 16, that's not possible. We have to get rid of that, and our only solution will be x equals 4. Okay, well, I am not doing so well, so maybe I should just tap out of this. But go ahead, try it, pause the video. Who knows? Maybe I'll do it right when we come back. Maybe I'll do it wrong. We're not sure yet. Okay, so that part is 2x plus 2. We know CA is 40. We know that BA is going to be 30. Oh, hey. It's just Pythagorean theorem. We can do this. So, sorry, CA was 40. We've got 40 squared plus 30 squared equals 2x plus 2 quantity squared. Four x squared plus 4x plus 4. So then left side is 2500, right side 4x squared plus 8x plus 4. Let's just divide everything by 4. Let's factor out 4 from the right side. And then we can divide both sides by 4. And we get 625. Let's see. No, I'm looking at the right side. I'm thinking, how are we going to factor that? Well, oh, duh, I got it. Okay. almost went off the rails again, but figured it out. Over on the right side, that is going to factor into x plus 1 times x plus 1. And then we're going to get, simplify that into x plus 1 quantity squared. Now we cannot say x is equal to negative 1. That's only when this is equal to 0. Right now it's equal to 625. So then we're going to take the square root of both sides. And we're going to get 25 equals x plus 1. And then we just have to subtract 1. There we go. And we get 24 is equal to x. Alright, this was an adventure. I have to apologize for that, but it's finally over. So here is the homework assignment. Check on Schoology for what I've marked as what is required and what is optional. Thank you for listening. The videos in the future will go a lot better than this.